All right, excellent. I took a look at the manometer problems, and people are did a real nice job for the most part. Some of the earlier ones that were submitted, and I want to continue that with today's notes and assignments. So what we're going to do is we're going to jump in just a few notes to make, and then I'm going to be making some references to the attachments that we have for today. So let's start by just jotting down a few notes, and this will be where we're going to be moving over the next few days, is talking about some gas laws. So as we look at how gases change under conditions of different pressure, is one that we talked about yesterday, and today we're going to add volume to the mix, and then we see how are volume and temperature related. So in talking about volume, we have already stated that gases are very unique in that if you have the same conditions, which is STP, that would be 273 Kelvin. Now notice that's a capital K with no degree symbol. And we're going to get to that when we do our temperatures and how to convert from Celsius into Kelvin. But 1 atmosphere, which you guys now know is 101.3 kilopascals, 760 millimeters of mercury, all kinds of different ways you could talk about 1 atmosphere. Usually talked about as ATM, an atmosphere with standard conditions. 1 mole of that gas would occupy 22.4 liters. Now that doesn't matter what kind of gas it is. It could be a little single neon atom or a diatomic fluorine gas, or methane. So all three of these gases would, if they were at those conditions, they would occupy the same volume. And when we talked about collisions, creating the pressure, the reason that this happens, that they would cause them to expand, if you think of an expandable balloon to the same size, is these larger molecules, like we'll use methane as being a little bit larger than hydrogen, for example. They are moving more slowly, but they are a bigger, more massive molecule. So the small ones, in order to have that same force as they're colliding into the walls of the container, are going to be really moving very, very quickly. All right? So that's how they can occupy the same volume, 1 mole. The same number of particles occupy that same volume because they're so spread out, and they're all traveling at different speeds, and that allows us to look at it that way. Now, in terms of the units of measure for volume, we're going to use liters most often. Now that, if you know what a centimeter is, like your little finger is about a centimeter. Now if you take 10 of those little centimeters, that would actually be a decimeter, and so that'd be about this big. So if you imagine a box that is a decimeter by a decimeter by a decimeter, that would be a liter. Okay. Sometimes you have larger volumes. We'll talk about a cubic meter. So these volumes can be singular units like a liter, or they could be the cubed quantities, because you have length, width, and height with volume. So for the smaller amounts, we almost always use milliliter, which is basically the same thing as a cubic centimeter. So you go back to your little finger, and a centimeter by a centimeter by a centimeter would be a tiny little cube that would have a milliliter of volume. And another way of saying that is cc, which of course, cubic centimeter. Okay, so those are the volume units that we're going to use. Now, what we're going to do today is we will use this to express the relationship between the different types of things like pressure, volume, and temperature. And today, specifically, we're going to talk about pressure and volume. So I'm just going to switch here real quick and show you some of the attachments that we're going to be doing some worksheets on. So in your classroom site today, there's going to be 3 different PDFs. One is, and you're going to get real used to using this one. These are the problems that we're going to be doing over the next few days. And you can see here there's a section on Boyle's law. So we'll be going through these different problems and setting them up and answering them. And there is an optional template that goes along with these problems. Okay, so I have, and we'll go over this in a little bit more detail in a second, but so that you don't have to write this down, 1A and 1B, I already wrote out here for you. So this is the format that we're going to use when we do these problems. And as you can see, there's also a key attached. Not only do I give you the answers, but the key is something that we can be using as well. Okay, so kind of use that key to help you out. And you can see there's a little bonus problem which does not have the answer, but I do want you to submit this, either the completed template or nice and neat in your notes, having the answers to these problems. Okay, so that's going to be what we're going to work on today. So like this this first problem, number 1 here, says convert the following gas volumes from the initial conditions to the new conditions. So it starts out at 100 centimeters cubed and 10.50 kilopascals, and you want to change that. What would happen if you changed your pressure to 9.91 kilopascals? So we'll go back to the PowerPoint here to answer that. So I have to kind of go through this volume thing again here because I backed it up a little bit. So this we already did. So this Boyle law problem. So Boyle's law, what it is, so this is for 1A, and again, you don't have to write this in your notes if you don't want to. You do have that worksheet template that is going to have the answers to all these. So that's Boyle's law, which is on the left side here are the initial conditions. All right, so you're going to plug in the numbers for the initial conditions, and then you'll change one of these. Now here's the thing about this type of relationship. This is one goes up and the other one goes down. If you put a lot of pressure on a gas, it gets smaller. Increased pressure, smaller volume. And this is called an inverse or indirect relationship. So when you're doing these problems, then we very carefully just plug in the numbers, and the order matters. First of all, they said the initial pressure was 10.50. Now, I'm going to let you leave the units out. You know how in stoichiometry we said you have to have the units and the substance. This is kind of the other end of the spectrum. Let's do these as more just math, sort of qualitative problems. And as long as you have the units for the final answer, we're going to be in great shape. Now, you wouldn't want to flip these two numbers because P1 has to be the first number. Okay? And if you flip those numbers, then you would be saying that you think that the pressure is 100, when in fact that is the volume. Pay attention to sig figs when you do this. Even though your answer will only have 3 sig figs because of this, don't drop that 0 off. Just write the data as is given. And then you set that up real nice and neatly. And then you solve for either P2 or V2 in these Boyle's Law problems. And of course, watch your sig figs when you do this. In a nice, neat, that's why I encourage you to use that template if you can, in a nice, neat little boxed format. So this is that problem 1A. All this stuff is worth points. You got to have the formula. You got to have the setup in the right order, and you got to have the answer with sig figs and units, and even this V2. So really follow the format that I provided for you. Okay, and then 1B is the same thing. You write equation, and with this one, your initial pressure was 97.3, initial volume was 50, and then you changed the pressure to 101, so you increased the pressure. And then you solve this, just multiply these numbers on your calculator, hit the equal key, divide by 101, and then round to 3 sig figs. Now notice what happens here. As the pressure goes up, the volume goes down. Okay? Right here, the pressure went down and the volume goes up. Okay, so pick these two examples to show you that concept. Okay? So, your assignment is to get this template completely done, work on that bonus problem, and then submit a nice picture of the front and back side of the template, or neatly written on a separate page in your notebook. Okay? So, and be sure to check your answers, and be a good proofreader. A lot of times we just kind of let stuff slide. Catch the little things. You know, if you're using, a capital M instead of a lowercase m here, catch those little things as you are correcting your worksheet. And remember to also continue to work on your lab report, your stoichiometry lab, alchemy, the mole lab that we did, where you're going to be doing a flow chart, and get your questions addressed on that. You don't want to wait too long. I said it's due on Friday sometime. Of course, by 11:59, by midnight, your lab report turns into a pumpkin and gets half credit. So keep that on the radar as well. But do all of the 13.1 Boyle's Law problems. Okay? Don't work past that. When you get to Dalton's Law, that's going to be brand new stuff. You're going to have to kind of know where to look up some of the data for that guy. Okay? But make this a really sharp worksheet, and follow the formatting that we have provided here for you. Okay? All right, so that is it for today.